In this section, we're going to review the file 4.pcap ng capture file. And I've got it open here in my Wireshark. So like we've done before, if you want to open it up and follow along, you can. And we're going to use the skills we've developed throughout the course to determine what has taken place on the network where this packet capture was taken. So once the file opens, you want to see what's contained within. We have the process we discussed in the previous capture file. So what we want to do is follow that same process. So as we start looking at this packet capture file, we see something interesting here in packet number 4. So in packet number 4, we have MBSS is the protocol. It's net bias session service, as you can see down here in the middle window. So what that means is this is net bias, which is a local area network protocol used by Windows for communications of names. So as you see in this packet number 4, we have 2 host names in this capture file that we can add to our list of things to track. We have one host that's called Vulcan_2, and we have another host that's called external DMZ. Again, these are 2 hosts that are going to be found within this packet capture because they're talking on a Windows network using the local area network protocol net bias session service. So right away we have this information because this protocol MBSS was designed for local area networks and it leaks information. So now we've got leaked information of 2 host machines on the network. So as a matter of a process, we can apply the following method. We know we don't care that much about things that respond as closed or not available. What we want to do is we want to discover what is available. So when we look at a packet capture like this, we want to find the open ports. So we can discover the open ports with a filter. So if we go back to our filter capability here, if we put in tcp.flags.send equals 1 and tcp.flags.ack equals 1, this tells us give me all the packets with the send flag and the ack flag set. So only the packets that responded to a request. Therefore, the packet found an open port. And that's what we're trying to do. From our perspective, we're only concerned with the ports that are open. As I've said, an attacker cannot attack something that's closed. All right? So now we have the packets that responded from the connection. As we start looking at this, we have the ports. So as you see here in the info section, it shows every port that was open because it responded with a send ack. So the left number is the open port. So now we know we got port 80, we got port 4328. So we've got ports of interest. Okay? Now, the next thing we want to do is look at data. Remember, our key is to find the open ports and then look for data. Because once a hacker or an attacker finds an open port, they're going to try to extract some information. Our job is to figure out what they extracted. So now I just changed my filter to tcp.flags.push equals 1. And I apply. This is all the data within this packet capture. So we had 2,184 total packets, and now we've reduced it down to 819. So only 37% of this packet capture file has data. That's why filtering and applying filters is so powerful. The next step in the process, we want to look for anything that's suspicious. And by suspicious, we mean, if you remember, we had the duplicate addresses. That was suspicious. But we also could have signs of a compromise. When an attacker singles out and attacks something, it's trying to get access. So to look for signs of a compromise, we're looking for things that might have access. So if we look at our packet trace here, and we go down here to packet 59. So packet 59 is interesting because if you look in the data portion here in the bottom window, there's what appears to be FTP data. But if you look here in the middle window or even the top window, the connection is port 80. If we have FTP, file transfer protocol, the normal port of communication is port 21 for FTP. So this is indeed suspicious. So what we want to do now is we want to investigate further, because what we have here, we have somebody connecting from this IP address at the 223 subnet into a web server, but they're talking to it with FTP. Definitely suspicious. So if I click on it, using our process we've continued to apply throughout, click on follow, TCP stream. Now when I look at it, I see, yeah, it's definitely a Microsoft FTP service, and somebody logged in with user anonymous, and they were access allowed, so anonymous access allowed. That means anonymous was allowed on this server, and they transferred a file. But the suspicious thing is, why is this coming over FTP, coming over port 80 or HTTP? So now we know that we've got traffic over port 80, and that's not normal. Not FTP traffic over port 80. But in this stream, this is where it stops. So if we apply our data filter again and continue with our process, we're still looking to find information of what's taken place. In this case, they transferred a file, but that stream terminates, and we don't have any additional information. So what we're going to do is we're going to perform analysis of virtually any packet capture to determine what has taken place using this same process. We looked for the open ports. We looked for the data. Remember our two filters we've shown. And then we look for suspicious. So we found suspicious here starting at packet 59 because we had connection to port 80 but using the FTP protocol. And that's definitely suspicious. So now when we go back here, we clear our existing filter and we select our push filter. And remember, we were at packet 59. So now we just continue down. So now, if we go down here further, once we get our data filter set and hit apply, we've got here packet number 102. So once again, we have data that is going to port 80, which was the initial thing. We saw they used the anonymous user login. Once they connected, they transferred some things and then left. But now look, we have FTP here, again, down in the bottom window. We can see we have an FTP server, and we have this FTP traffic coming on port 80. So again, this is suspicious. So what do? All we have to do once again is we right-click, follow TCP stream. Now we've got some interesting things. Remember, blue is the actual, in this case, the client sending the information because the server is responding. So when you look at the response, what do we have? Well, we had the anonymous user in our one before, and now we have the FTP user. But more suspicious is this thing here, right here, this bin SH1. Now, if you don't know what that is, it's a bin shell. So they're trying to get a shell on the server using a vulnerability in the software that's running this service. As we scroll down, we see these site exec calls. Site exec is what's actually shown in this FTP version to execute information and data. And it's being passed this AAABCD. But then it's got these things called %Fs, F%, all that type of stuff. What is that? Well, if you're familiar with the programming language of C, this is the signature of an attack. It's what we call a format string attack, because format strings are what identifies to the C language what type of format the data is going to be composed of. So that's what we have. So now all these site execs are trying to get control of the machine and get access. So as we scroll down here, what we're doing is we're looking for signs of a compromise. So far, nothing's been compromised because we continue to see all this data going in. But remember from where our password was entered, we've seen that string bin sh. So they are trying to get with that bin sh a shell. So as we start going down here, now we've got some data. So now what happens is something's changed. The address is changed. Now it's got access to what we call our shell code. Now when we run shell code, what we're trying to do is take control of the application and run a shell. And again, these are things you'll learn as you build your skills, and we continue on. As I get down here, I've got a response. And it's a Linux localhost, local domain. As you start looking down there, you see right here, UID equals 0. So what we have is, this shows us that a shell was returned to the attacker, and not only a shell, but root level access as well. That's indicated here in the UID equals 0. This machine has been compromised. And in this stream, they stopped once the compromise was successful, as indicated here in red. So all they did was get the shell, execute here in blue, the ls command, and then they executed the quit and realized that they were in the wrong type of shell, and they executed exit. Once they executed the exit command, they terminated their attack. So now in our analysis process, we figured out there definitely was an attack here. There was a compromise of this machine. So if we close down this stream, we'll look at one more. So if we go to packet 1211 in the trace, so we'll do a little technique, go to packet, and we enter 1211, and we click on go to packet. Now we've got the same type of thing, port 80, and we're looking to see if the attempt of the attack was successful. So using our process that we've perfected throughout, right click, follow TCP stream. In that case, you've got scripts %C0%AF, that's a / in Unicode, and the attack wasn't successful, but they uncovered, in this case, a very old version of Microsoft's IIS server 5.0. So that would be a concern. So if, say, let's use a scenario. You were looking at this for a client. You would go back to the client and say, this machine, indicated here with the Microsoft IIS 5.0, is at a high risk of being compromised. Then you would look at the network diagram with the client and see what segment is this machine on and what can we do to protect it. We can't just go in and say update to a new server. We don't know why that machine's running Microsoft IIS 5. So as you get more skills and knowledge and experience, you help the client mitigate their risk. And that's our job as a professional security tester, which right now we're building your foundational skills. So since it didn't respond with a 200 OK, this wasn't successful. So let's see if we can find a successful one. So now we're going to go to packet 1495. So now if I go to packet 1495, using my same go-to packet technique, same thing, port 80 traffic. Oh, this is 4463 traffic. So here I am at packet 1495. If I right-click that, follow TCP stream. Now we have a little bit different. Remember before we got a 500 error and nothing happened. Now this packet has returned that this machine that's running that Microsoft IIS 5 box is actually a Microsoft Windows 2000. And not only that, it returned a shell to the attacker. We see this is indeed a compromised machine. So now we would go to the client and tell them this machine located here has been compromised. And then we would help them identify what their policy is after an incident and help them do their incident response plan. Now, all we see so far is, in this packet capture, the one we're looking at here, all they did was compromise it, get the shell, verify that they had the shell, Microsoft Windows 2000 was the version, and they hit exit. So in this trace, yes, the incident report would say the machine was compromised, running a very old version of IIS. We've seen that %C0, %AF. As you build your skills, you get more knowledge, you'll understand that's what we call directory traversal attack, something that this version of IIS and a lot of other versions of IIS are very vulnerable with. So now this is what we want you to understand. Now that you have this process, you've built your skills, you've built your foundation, the more you practice, the more you can identify how to analyze network traffic using protocol analysis, using the Wireshark tool, which makes it much easier by using filters. And this concludes pretty much the course. Next up, we'll close out the course. But now you have the skills and the foundation to do protocol analysis in Wireshark. It's an exciting world. Have fun with it.